All right, y'all. So we've taken our quiz over, or we should have at this point, over Pythagorean theorem and special right triangles. Now we're going to get into the other side of right triangles, which is called trigonometry. Okay? Trigonometry is the study or the measurement of triangles, essentially. And you can go far and far into trigonometry. In fact, some of you may take the pre-calculus class here that we offer at the high school. And part of that is devoted just to trigonometry. We're doing the very, very basics of trigonometry, okay? So we're going to talk about those three things: sine, cosine, and tangent, and talk about what they are, and then we're going to use them to find a missing side or an angle in a triangle. All right. Um, Again, this is the very basics of trigonometry. So I'm going to take a little bit of time to talk about what sine is, what cosine is, and what tangent is, and then we'll show you how to use it. Okay. Now, sine, cosine, and tangent are all ratios. They are relating one side of the triangle to another side of the triangle. They're very specific in how they relate them, okay? So, the sine ratio, so first of all, let me show you. I have the same right triangle for every time we're going to talk about this. Angles A, B, and C. And then generally speaking, when you name the sides of triangles, the letters should match up crossways. Like angle A is across from side A. Angles are capital, sides are lowercase. And then the B's go together and the C's go together. Okay? The sine ratio, it's the ratio of the opposite side to the hypotenuse. Okay? Now, depending on which angle you're referencing from, because the way you use trig is, first of all, when you actually use the trig ratio, sine, cosine, or tangent, we always abbreviate it. Okay? So this looks like sin, but do not call it sin. Please, for all that is good in this world, do not call it sin. It is sine. Even though you're using a part of the whole word, you still pronounce the whole word in this part, okay? So we will pronounce that as sine of A. And when you use a trig function, sine, cosine, or tangent, you always reference it from an acute angle. And I say acute because we never reference from 90 in this situation. Okay, we never go from the 90. We always go from one of the other angles. They will always be acute. Okay? So sine of A, which means we sit here at A, we need to find the side opposite and the side that is the hypotenuse. Okay? So sine is opposite and hypotenuse. Opposite goes on top, hypotenuse on the bottom. So from angle A, look across the triangle. That means opposite is to go through the triangle across. The opposite side is lower a, little a over. What's the hypotenuse? Hypotenuse is always the longest side, so this is C. So we'll write that as A over C. Now, in reality, A and C are going to be numbers, okay? Or one of them could be missing, and you'll have some angle answer here for A, and you're trying to work it out. And we'll talk about that in a minute. But that's all you do. To write the ratio, it's the opposite side over the adjacent side. Sorry, I said that wrong. The opposite over the hypotenuse from wherever angle you're referencing from, B. Actually, that's A. Now we switch to B. So we go look at B. Look across the triangle for the opposite side, little b, over the hypotenuse C. So the hypotenuse stayed the same, but the opposite side changes based on where you're referencing from. All right? Cosine is sine's best friend. It's the ratio of the adjacent leg to the hypotenuse. And adjacent is just a fancy word for next to. So the side that is next to the angle, okay? So when we use cosine, we abbreviate it COS, but we still call it cosine. Do not call it cos. So cosine of A. So we come back here and look at A. We want this side adjacent. Okay, the leg adjacent specifically, the adjacent leg. So that means we come straight down. In this instance, we come straight down. Okay, we're not going to go this way because that's the hypotenuse. We don't need to go there first. We need to go to the other one first. So this is going to be B, little b, over the hypotenuse, which is C. Now we switch to angle B. Cosine of angle B, instead of going across, you go next to it. So that would be A over little c. And yes, this is supposed to happen that sine of A equals cosine of B. There's a whole reason for that, and if you take the actual pre-cal class, you'll understand where that comes from. But I'm not going into that. But those are your ratios for that one. Now let's look at tangent. There we go. All right, tangent. So tangent is sort of like sine and cosine combined. Tangent is the opposite, the ratio of the opposite leg to the adjacent leg. Well, my OCD, I can't figure out what kind of T I want. There we go. And I forgot to spell opposite. Look at me. Tangent is the ratio of opposite leg to the adjacent leg. When we actually use tangent, we abbreviate it TAN. It looks like tan, but we don't call it tan. We call it tangent. Please call it tangent. Tangent of A, so we look from A. So we start with the opposite side, so we come all the way across and start with A. Over the adjacent now. So now we come, not the hypotenuse, the other one. So that would be B. And then we switch to capital B. Tangent of B, the opposite is little b, over the adjacent side now is A. So see how these two switch? That's supposed to happen, but all right, so that's the ratios, sine, cosine, and tangent, and how you use them. And here's an acronym I always tell my kids. It's what I was taught in school. So, let me space this out a little bit more. TOA, SOHCAHTOA. And it stands for that sine is the opposite over the hypotenuse. That's what it's supposed to help you remember. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? SOHCAHTOA. SOHCAHTOA. Always remember that. SOHCAHTOA. If you need to, put it at the top of your paper. SOHCAHTOA. So that you know which two sides go with sine, which two sides go with cosine, which two go with tangent. Okay? Now what we're going to do, so now that we've sort of talked about what they are, we're going to use them. We're going to write the ratio. Okay? So I want you, for these three, I want you to write each trig ratio for angle X as a fraction in simplest form. So you're going to have to tell me. Now, in actuality, you're probably only going to find one at a time. But I just went ahead and combined all three right here so we could get practice with all three. So we got to do sine, cosine, and tangent. So when you use sine, cosine, or tangent, you use the abbreviation and then the angle that you're referencing from. They told me X, everyone is going to have a capital X. Okay? And I always like to circle the angle I'm looking at or referencing from. So angle X, let's start with sine. Sine is opposite over hypotenuse. So from X, I'm going to look all the way across the triangle. So this would be the opposite. So 40 over my hypotenuse. Now be careful, this triangle is turned a little bit differently. So what I do to find my hypotenuse is I look for the 90 and then go across. 90, go across, and that makes this the hypotenuse. And I about wrote H instead of 50. So 50. And then if this is opposite and hypotenuse, that means that 30 is adjacent. And this might be helpful for you. From the angle you're talking about, label your sides appropriately. Opposite, adjacent, and hypotenuse. That might help you. Okay? So when you first set this up, you get 40 over 50. But we know that reduces. So I want you to go ahead and reduce it. That will reduce to 4 over 5. And of course, if you don't know that, you can use alpha y, type in 40 over 50. Boom, there you go, 4/5. Cosine of x. Cosine is adjacent over hypotenuse. So from x, my 30 is adjacent because I labeled it earlier, and I still use the same hypotenuse of 50. And I need to reduce that, so that's going to reduce to 3/5. Tangent is opposite over adjacent. Opposite, adjacent. So this is going to be 40 over 30. That will reduce to 4/3. So that's what I want. I want the simplified fraction answers. Let me put boxes around those instead of lines. That was kind of strange. I want simplified fraction answers, people. I guess I'll take decimals, but I would really prefer fractions. All right, so same thing, but now we're going from angle Z. So I'm going to circle Z. So we've got sine of Z, cosine Z, and tangent Z. Sine is opposite over hypotenuse. So from Z, go clear across the triangle for opposite. There's the opposite. Let me label that clearly. Opposite. Where's my hypotenuse? So right here's my 90. So go across to find him. Right there's my hypotenuse. And then that would make this my adjacent that I'll need later. So this is going to be opposite 21 over the hypotenuse of 35. And you could use alpha y equals to type that in if you don't know how to reduce it. 21 over 35, we get 3/5. All right? Cosine Z. Cosine is adjacent over hypotenuse. So I'm going to do my adjacent 28 over hypotenuse 35. And if y'all reduce that, it gets 4/5. Tangent is opposite over adjacent, so that's going to be 21 over 28. That will reduce to 3/4. All right? So that's the basics of trig that I need you to know how to do. Well, first of all, is to one, remember what sine, cosine, and tangent are, and two, be able to write each ratio for an angle, or a ratio for an angle. Okay? What we're going to get into now is actually using trig in a right triangle to find a missing side or a missing angle. Okay? So, and this will be what your problems look like. It'll say find the missing side, round to the nearest tenth, and all I'm going to give you is an angle and one side, and you'll have to find the other side. Okay? Just find one extra side. Now, the trick to all of this, is to first figure out if you have sine, cosine, or tangent. You have to be able to figure that out first. How do we do that, Mr. T? Well, we have to look at what they gave us. So we always reference from the angle that's not 90. So if you need to, circle the angle that's not 90. So in this instance, we're going to go from 40. And based on the 40, where it's sitting at, I'm going to look at what they gave me. So this side labeled X is next to my 40. It's not across, it's next to. That makes it an adjacent. The 17 is across from 90. It's also next to, but it's across from 90, so that makes it the hypotenuse. So I have the adjacent and the hypotenuse. Who uses the adjacent and the hypotenuse? That's cosine. So this is going to be a cosine problem. And if you need to, before you start working it out, write down what kind of problem it is. Cosine. And then we'll use it. Cosine of your angle, so cosine 40, equals, and then set up your adjacent over your hypotenuse. Adjacent here is X, and your hypotenuse is 17. Okay? One of the pieces is missing, so we have to use this little equation here to find it. It looks complicated, but it's actually very, very easy. So, now we're going to turn to our calculators for a minute, and I need to explain something. Every time you pick up one of these calculators, I want you to, especially for me, I want you to double check something. Turn it on, and I want you to hit this mode button. Go to mode, and this big old list pops up. You need to go to this third line right here where it says radian or degree. Mine is already on degree. Okay, you need to make sure that your degree is highlighted. Okay? You want to be in degree mode because we measure angles in degrees. If you get into higher up math, sometimes you measure angles in what are called radians, and we don't do those in this class. We're just doing degrees. So double check every time that you are in degree mode. And then to get out of here, you hit second mode and it takes you out. Okay? Now that we're in degree mode, we can solve this. So we can essentially do a cross multiplication problem because this is a fraction and there's secretly a divide 1 under here. So we'll do x times 1, so x equals 17 times that, and I always write it with the 17 first. Okay. So I mean, if you want to, just recognize that this, let's do it this way. This always multiplied with this. Just get in the habit of doing that every time. So 17 times the cosine of 40. X is going to be that value. That is really just a big nasty number, and we'll just use our calculator to get that. 17. Where's cosine? He's right here. So just hit cosine, and then type in your 40, close it, and hit enter. Now, more than likely, you're going to get big nasty decimals. Okay? That's just how sine, cosine, tangent work. So I've instructed you to round to the nearest tenth. So we go to the first decimal place. It's a 0. Look behind it. That's a 2. So he'll just round down. So this is really just going to be 13. And that's it. That's all you have to do. Once you figure out who it is and do this little multiplication, it's a breeze, okay? So let's keep going. We go from 36. I'm looking what they gave me. I have to go across the triangle to get to this x, so that makes it the opposite. 19 is across from the 90, so that makes it the hypotenuse. Who uses the opposite and the hypotenuse? Well, sine does. So we're going to do sine 36 equals opposite over hypotenuse. These two get multiplied together and just bring your x down. He's on top. So 19 sine 36. Type in your calculator. 19 sine 36. That's going to round to 11.2. I think once you understand the trig and how it works, this is very, very, very simple. It's all calculator work. You don't have, now, back in the day, they did it all by hand, but alrighty. We go from 31. Notice I go through the triangle to get here, so that's the opposite. But now look at this case. The x is up here. It's next to. And it's not the hypotenuse. That's a leg. So that makes it the adjacent. So this is a tangent problem. So we'll have to write tangent 31 equals the opposite over the hypotenuse. Now, in this instance, your work is a little bit different because the x is now in the denominator of your fraction, of your ratio, okay? So you're still going to do this first step. Multiply x times tangent 31. X tangent 31 equals 17. So this is x times tangent 31, okay? Now we'll just divide the tangent off because that's essentially a number. So divide it out. Tangent 31. So x is going to be some number, and we'll just type this in our calculator, okay? So a couple ways you can type it. I always do alpha y equals 17 over tangent 31. I do it that way. Or you could do old school, just like that. All right. Either way, we end up getting 28.3 when you round. And this last one's just to double check that we know what we're doing. Also, before I get to that one, notice on the cosine and sine we had x on top, and the tangent problem we had x on the bottom. That was just luck of the draw. You could have either variation of this fraction for any sine, cosine, or tangent problem. Okay. My point being is, if x is on top, this is all the work you do. Just this bottom times whatever the trig is. Over here, when x is on the bottom, it's the number divided by the trig. Okay? So 27, I have to go across to get to him, so that's opposite. This is next to, and it's a leg, so it's adjacent. So this is another tangent problem. So tangent 27 equals 18 over the unknown. This setup is similar to this one. So I'm going to take a shortcut and just do 18 divided by tangent 27. I'm going to double check. 18 over tangent 27. And we get 35.3 when we round. All right. So that's how you use trig to find a missing side. That's the very first application of it. The other application, which I like it all, but this is kind of fun, is you can use it. You can use it to find a missing angle. So you'll have two sides of the triangle labeled for you, and you want to find the angle. You still need to figure out if it's sine, cosine, or tangent. Okay. You always want to figure out if it's sine, cosine, or tangent first. So we always go from here. Now, I like to do this a little bit differently. Instead of calling this x, I like to call it this, that symbol. So in case you're wondering, that symbol, that's called theta. It's the Greek letter T. And in trig, it's used a lot of time for angles, okay? Angle measures. I personally like to use that just because it's Greek and it's kind of fancy, and also because it's T. My name's Mr. T. But anyway, if you don't want to use this and the Greek freaks you out, just use a capital letter. Use capital X or whatever. Capital Z, it does not matter to me. Just make sure it's capitalized. All right, so let's figure out if this is sine, cosine, or tangent. So from the angle, notice I have to go through the triangle to get there. So this is opposite. 38 is across from the 90, so that makes it the hypotenuse. So this is a sine problem because I have the opposite and the hypotenuse. So sine of the angle, remember you could use capital X or whatever if you want to, equals the opposite over the adjacent, the hypotenuse, wrong word. Now, how are we going to do this? We've always had an angle right here. Our unknown has always been over here. Now it's over here. Well, think of it this. I want you to think about it this way. The sine, cosine, or tangent is essentially a function, okay? Which means it's going to have an inverse. There's something you can do that makes sine or cosine or tangent go away. So look at your calculators for a minute. We always hit these buttons, sine, cosine, or tangent for those. Look above button. What's written there in blue? There's a sine -1, cosine -1, tangent -1. That's the inverse. That's called inverse sine, inverse cosine, inverse tangent. We use those to make regular sine, cosine, or tangent go away. So let me show you. Essentially what we'll do is we're going to drop the sine from this side and make sure we put his inverse over here. So just drop it, put your angle, and then make sure you put the inverse over here. Okay? So you drop it over here, make sure you put the inverse over here. And now this is what we'll type in the calculator. Inverse sine is written in blue, so I have to hit the blue second key to pull it up. And then just type in your fraction, 36 over 38. And then you get that decimal. Now you're always going to get a decimal for these, almost always. There's a couple of times where you can't. But look how I want you to round it. Find the measure of the angle to the nearest degree. That's, in other words, nearest whole. So 71.3, that's going to round down to just 71. So this is going to be 71 degrees. Make sure you put degrees because I'm talking about angles here. I want to see degrees. All right. So this is our process, and we'll change sine out for cosine or tangent whenever they pop up. So right here's my theta, or capital X, whatever you want to call it. So from this angle, notice that I have the leg next to it, so that's the adjacent, and the 45 is the hypotenuse. So this is a cosine problem. So cosine of my angle equals my adjacent over my hypotenuse. So this time we'll drop the cosine and make sure to put the inverse on the other side. We'll use inverse cosine to type that in. I'm going to type it in this way, divided by, oops, that is not 35, that is 45. That rounds to 40.9, so that's really going to be 41 degrees. Okay, it's kind of bothering me. Let me fix that. Okay, last two. I promise I'm almost done. This video is a little bit longer. There's a lot involved in this. Right here's theta, or capital X. I have to go across the triangle to get here, so that's opposite. And then this is the leg next to it, so that's adjacent. So this is a tangent problem. So tangent of my angle is opposite over adjacent. Drop tangent. Make sure to put inverse on the other side. And then use inverse tangent, so make sure you hit blue. A 5 over 10, and that's going to round to 27 degrees if you round to the nearest whole. 27 degrees. And one more just to make sure you know what you're doing. Here's theta. This is the opposite. That's the hypotenuse. So this is another sine problem. So sine of my angle equals opposite over hypotenuse. Drop sine. Put the inverse over here. And you type that in the calculator and round it, it's going to be 52 degrees. All right, there you go. That is all the trig stuff that we're going to do. So you have to be able to recognize sine, cosine, and tangent, what they are, how to write the ratios, how to use the ratios to find the missing side, or how to use them to find the missing angle. Okay? So let's make sure we watch the video all the way through, we get all the notes, and complete your homework assignment. It is a little bit longer. I think it's 27 problems, but I want to make sure you had plenty of practice with all this stuff because this is super, super important. Okay? As always, if you need help, please let me know.